Hey guys, Villani here, how are you? So, continuing on the last video about materials, we'll talk about textures today. This video will have about 10 topics and I'll leave their times on the video description so you can access them quickly if you're interested in one in particular. I'll first create a material here. Right click, material, m_textures to tutorial. I'll create an instance from this material so later it's easier to edit and see its parameters. I_textures tutorial. I like to keep my instances and main materials separated. Okay, I'll create a mesh here if I want to test this in the world and apply my instance. Now let's edit the material. Where is it? Okay, the first thing about textures. How do you create texture nodes? You either right click and choose texture sampler. Where is it? Texture sample, or you hold letter T in your keyboard and click. Now that you created the texture node, you have to select the texture. To select the texture, select the node, go here in the details panel, material expression texture base, and select your texture here. I've created a texture especially for this tutorial. I'll leave this PSD file for you to download in the video description. The texture node, it outputs all the separate channels of the texture R, G, B and alpha, and it has this white output that represents R, G and B in one. It's a float 3 and all these others are each one a float 1. It's the same thing as you create this node or this node. This is like the white output and this is like each one of the individual channels. I'll plug this in my base color so we can see the result. I'll compile the material. So as you can see, my texture is now applied to my material in the base color channel. Going back to the material, you can also use one of the individual channels, but these channels, they're black and white because they're not a mixture of R, G and B. Each one of them are just one value from 0 to 1. So if I use the red channel for example, I'll click on plane here so it's easier to see the texture. You can see it's using only the information I have on my red channel. If I plug in the green, this is my green channel and this is my blue channel. You can also plug in the alpha, as each one of them are simple float values. Before I continue with anything else about textures, I want to show you something that is a very common problem. So I have my texture selected here, and the sampler type Unreal chose automatically for me when I chose the texture, so it's color. If I edit the texture by double clicking it, you can see my compression settings are in default. If I select other, for example masks, you can see masks has no sRGB. I selected, and now my sRGB is unchecked. So my texture is not in sRGB color mode anymore. It's linear. It changes the way Unreal will read your colors. So the texture must be specified as another type here. If I try to use this texture now, you get an error. This is a very common error, and many people don't know how to fix it. You just need to fix your color type here. So I selected masks there. Here I just select masks. Sometimes it's not this type of change, so I'll go back to default. You see Unreal already pointed me the error. My sRGB is turned off, so it's not masked, but it's not sRGB either, so I have to select linear color. So always remember to keep this option in sync with whatever you choose here. Now let me open the material instance I created earlier to show you something interesting. Materials, where is it? Material and my textures tutorial. Let me compile this material now that it's working. You can see here in my material instance that I don't have a way to change my texture. So I need to convert my texture to a parameter. I'll right click it, convert to parameter. Now if I click here in the name, I can rename it. Name, let me see, color, texture, for example. Apply. Now in my material instance, if I wanted, I could change my texture. See? I'll go back to my default texture, go back to my material. Actually, let me go to the scene. I want to explain something. So okay, I chose a texture and the texture is laid out correctly in my square. At least it's laid out correctly in each of its sides. How do materials decide how your texture goes into your material, how it's rendered in your object? Let me explain you something about UVs. I'm here in 3ds Max with a box similar to the one in Unreal, but with different UVs, different mapping. Mapping or UVs are the way you map your UVs for some position in a texture. So let me show the texture here. Okay, this is my texture, same one I'm using in Unreal, and here's what each of my vertex translate into the texture. So you can see if I move this, the texture is applied differently in my box. I can move a whole face, it's this one here. So that's what UVs are. This will be very important later. Their positions go from 0 in this corner, 0x, 0y, from 1 in this corner, 1x and 1y. So this corner here is 0x, 1y, and this corner here is 1x, 0y. Think of UVs as U being x and V being y. Now let me go back to Unreal. The way the textures are rendered is, it reads the position of the vertex in UV space for this vertex here, and it renders the pixel of the texture that is in that position. From all the way from this corner to this corner, it will blend from the texture position in the UVs here to the texture position in the UVs here. So you don't need to have vertices here for the texture to change between here until here. The video card does this automatically for you. Now why is it important to know this? If you want to manipulate your texture in your material, like make it repeat or make it grow or get smaller, you have to work with the UVs. You will have to manipulate them. So I'll create a UV coordinate node here, hold U and click, or right click and type coordinate, texture coordinate. Okay? What this is think of a material of all the math you're doing here will be calculated for each pixel on the screen. So it's like you're inside a loop, and this loop walks you through each pixel on the screen. So this node here will represent the coordinate you are for the pixel being rendered. So for example, in this face here, when Unreal is rendering the center here, it will take the pixel coordinate blending from this vertex to this vertex, or this to this, so it knows which pixel of the texture must be rendered here. If this is UV00 and this is UV11, this will be 0.5, 0.5, U.5, V.5, or X.5, Y.5. So this coordinate here is the coordinate of whatever pixel is being rendered. This is only a float 2. It has U and V, or Y and X. Whenever you try to use these values in channels like base color that expect RGB values, it will use the first two values. So R and G will be my UV. If I apply this, so you can see it in the cube. Now you know how this cube is mapped. Each coordinate going from 0, 0 to 1, 1. Each phase has uses the same coordinates. You know this because up here, red is 0, and going to the right, red is 1. On the left, where red is 0, going down, here is 0 green, and here is 1 green. And in this corner here, you have 1 red and 1 green, which gives you yellow. So now that you know this, what can you do? You can remap the texture. For example, if I want to repeat this texture, let me go back to 3ds Max to show you something cool. What happens if my vertices are outside the texture square here? Okay, I have a lot of vertices outside the texture square, but the texture is still working. There are no black parts or whatever. How is this? The video card automatically, it's a standard. You can change this behavior, but it's a standard. It will repeat your texture in each direction. As you can see, whenever my vertices are outside the texture UV square, it repeats the texture in the other squares. So this is very useful to do tiling. Tiling is when you repeat a texture several times. I'll go back to Unreal. Let's do tiling on this texture. I'll hold S and click twice to create 2 scalar parameters. I'll call this one tiling U for horizontal tiling and tiling V for vertical tiling. I'll leave this both of them in the default of 1, and I'll multiply my texture coordinate by these 2. As my texture coordinate is a float 2 and each of these represent a float 1 value, I need to create a float 2 from them. Unreal has a node for this called make float 2. There's also another way without using Unreal functions. Remember, these blue nodes are functions. You can double click them and edit how they work. And as you can see, you can use append to join floats together. You can do append several times to make, for example, here we have a float 2. I'll create another float 1, and you can use append to create a float 3. And you can do this for float 4 also. You get the picture. Now I use my float 2 to multiply by my texture coordinate and use the result as my texture UVs. So you won't be using the material default UVs anymore. It will be using the UVs I changed here. I'll apply. And let's go to the instance to see the changes in real time. I'll first show you what it does, and then I'll explain you how it works. I'll set it to 2 in U and 3 in V. Let me choose a texture that shows the result more clearly. Something very easy to see the pattern. So you can see my texture is repeating twice in horizontal and 3 times in vertical. Do you remember when I told you that the textures go from 0 to 1? What happens here is I multiplied the texture by 2 in horizontal and 3 in vertical. So when my material tells Unreal, here's coordinate 0 and here's coordinate 1, I'm multiplying it by 2. So here's coordinate 0 and here's 1 times 2, which gives you 2. So it's going from 0 to 2 with 1 in the middle. So my texture is being mapped from 0 to 1, which is the whole texture, and from 1 to 2. And as you saw in Max, when you are outside the 0-1 range, it repeats the texture. So it's the same thing in the vertical coordinate, from 0 to 1, 2, 3, because from 0 to 1 I multiplied by 3. You can also use values lesser than 1, 0.5 and 0.3. So now my texture is bigger, because instead of mapping the image that goes from 0 to 1 to a 0 to 1 in the plane, I'm mapping it from 0 to 0.5 and 0 to 0.3, so the texture is cropped in the material. As you can see, it works the same in my mesh. Now the texture, even though I can change its size, it still holds the corner here. So what if I want to move the texture within the object without changing its size? I used multiplication to change my texture scale. To move the texture, you need to move numbers. What if you want to change 0 to 1 for 1 to 2? You didn't change the size. You only change it where it begins and where it ends. It's an offset. To do an offset, you use adding operation. So I'll hold A and click to create an add node. Plug my texture coordinate here. I'll copy these two. You can do Ctrl+C, Ctrl+V to copy the nodes, Ctrl+C, Ctrl+V, or you can do Ctrl+W to duplicate the selected nodes. I'll call this offset U and offset me, no kidding, offset V. I'll leave the defaults as 0, so my texture is not offset for start. I could have copied these together, but okay. And now I plugged this wrong. You could plug this way, but then you lose the multiply. What you can do to make them together is use the result of the multiply and offset it later. If you offset it first, remember, for example, 0 plus 1 equals 1 times 2 equals 2. Now 0 times 2 equals 0 and 0 plus 1 equals 1, so the result will change. I prefer to leave the offset after the multiply. So first I scale the texture and then I offset it by some value, knowing the result will not be changed by the multiply value or the tiling here. Now I'm gonna compile the material, clicking apply, and see its results in my instance. So if I change the offset U, you can see the texture changing. It's really weird the first times you do it, because if you go positive, the texture walks left, and if you go negative, the texture walks right. Same thing but in vertical with the offset V. It's inverted because, as we talked earlier, 0.5. Let me change the tile to 1 here. It will be easier to explain. 0.5 is the middle of the texture. So if here's 0 and I'm adding 0.5, it will read the middle of the texture. So as I make this value bigger, it will be reading more to the right of the texture. Remember, the texture is represented by 0 to 1. So if I change the coordinates to read greater values, it will be reading up to the right bottom corner of the texture. And this is how you do tiling and offset in textures, manipulating the UVs. I'll change these back to the defaults, so we can talk about something else. Well, it's really cool to use the texture, and you have a base color, and you have an alpha. For example, if I change this material to masked mode and use this texture alpha as opacity mask, I'm using the same texture I was before, but using it for two material outputs, the base color and the opacity. You can do this in a more advanced way by using each channel of the texture for something different. So for example, instead of using all of its color to the base color, I could use a separate texture only for the color, or in this case here, to be quick, I'll do I held V and click it to create a float 3 node. So I'll call this base color and give it a default of something blue. And this texture, I can use it to represent many things. So here, I'll use the red channel to represent my roughness, the green channel to represent my metallic, and the blue channel is a texture I made. You know what? I'll use the blue channel to mix two colors together. So I'll duplicate this base color. I'll call it color 2 and color 1. And I'll give this pinkish color. There's a node in Unreal very useful to mix two things together. It's the linear interpolate node. You hold L key and click, or right click and choose linear interpolate. What this node does is, it will take the values of A and B and mix them according to an alpha. Remember when I told you the material is like you're inside of a loop that gets executed for each pixel on the screen? So if I take the value of this blue output from the texture and plug in the alpha, for each pixel it will read one pixel in the texture, and if the value is closer to 0, it will use the value of A, and if the value is closer to 1, it will use the value of B. So I'll plug this in my base color, and as you can see, I'm mixing from the blue channel. Let me preview only this one. Right click, start previewing node. So as you can see, I'm mixing using the blue channel these two colors. So Lerp is very good to mix two things based on some float value. And as a texture gives you a different float value for each pixel on the screen, you can create several effects with this. I could also mix two textures here instead of only two colors. So the possibilities are infinite. I'll stop previewing this. I'll make my material opaque again because I don't want this alpha channel to be cutting off, and I'll compile. Let's see the result here. So my green channel is white on these dots and black on the rest, and I plugged it in the metallic channel of the material. So it's metallic on the dots and non-metallic on the rest. My red channel, I plug it into the roughness. I'm changing these colors because it's really hard to work with them. I'll do a slight different blue here. Okay. The roughness, I used my texture's red channel to do the roughness. So as you can see, it's varying throughout the object with an interesting pattern. It's not the whole object using a single roughness value. And my blue channel, I use it to mix these two colors. You can use it in whatever manner you like. I could use the one I used in roughness for the metallic, the texture I used to make my colors, I could also use it in roughness, so it will give the effect like this color is less rough and this color is more rough. And also I have a metallic pattern now, so it's much harder to distinguish what's metallic or not. And as my texture is using those mapping coordinates math we did, I can also manipulate all of these channels at once. Think of the way I mixed the two colors here as a mask. So if I had patterns in this texture, a pattern on red, a pattern on green, and a pattern on blue, I could use these patterns to mask different textures here. I'll do it. Let's do it. T. I'll choose that Unreal Alpha. And the Unreal default texture is a green something. Default texture. So my base color will be a mix of this alpha texture and this green texture. I'll apply and edit my instance so the texture is bigger with less tiling. Oh, a little more tiling. So you can see the pattern. I'll mask the textures using the dots channel because it will be much easier to see. See, you can use this for masking. Oh, and also, my default texture and the real alpha texture are not being tiled because I'm not using the same mapping here for the other two textures. If I did, they would be tiled and offset just like with the first one. Now I can repeat them too. And if I change anything here, everything is in sync. You could also create different mapping values and parameters for each texture. You'll have to copy these values and use them instead of the first one we created. So you could move everything separately. I won't do it here because it's not needed now. I'll leave these two textures, they are interesting. Now let's talk about animating the texture. Instead of mapping these to a custom value, I'll animate them. In Unreal there's a node called Panner. You can hold P and click to create this node, or right click and type Panner. What the Panner does is it moves your texture in one direction a long time. So it takes a coordinate input. The coordinate input can be your texture coord, or if you input nothing, the default is your texture coord. Why do you have this option if nothing is the same as plugging in? Because do you see this 0 here in the texture coord node? If I duplicate this and go to its details, I can change its coord. This is because when you model something, you can create more than one UV mapping for that mesh. So you can use the first mapping to, like in this box, every face has the same mapping. You can use the second one to do the same mapping I was using in 3ds Max, and use them all at the same time here by choosing which coordinate you want. The first one is 0 and the others go 1, 2, 3, etc. So I'll leave the coordinate here as the first one, the default one. The time has to be something that changes a long time, and the materials in Unreal has the perfect node for it called time. Oh, time. I'll plug time here. Now my speed. You see in the specification, in the tooltip, it's a vector 2 or a float 2. So you can set a speed, the same speed with a float 1 for both, like 0.1. For both directions U and V. So I'll plug this in this texture and let's preview this texture. I'll turn on here, live preview is on, it was supposed to live preview. Okay, it's not. It only works when I move here, so I'll keep moving slightly so you can see the effect. My texture is going 0.1, my coordinates actually are being changed 0.1 each frame. So remember when I drag the offset to the right, when going higher in the values, it walks the texture to the right and to the bottom? That's the same thing I'm doing here. And I'm going 0.1 at each second in the positive directions in U and V. I can separate these by using two values. So I'll make a float tool here by holding 2 and click. And I'll set this 0.1 and minus 0.3. So I'll walk in horizontal to the right and in vertical to the bottom. Yeah, I never remember. This inverted thing confuses me. And as you can see, you can control both directions separately with different values. And the panel will take care of this for you. What if I want to change the speed from blueprints or in a material instance? I can't control time from outside here. So what you can do is multiply time by some value. I create a scalar here. I'll call it time scale. Leave it at the default of 1. And plug it here. And then use this as time. I'll compile this material and go to the instance so we can see changes in real time. Now as you can see, my checker pattern is moving, and if I change the time, let's see this in the world, because it will be in real time, so I don't need to keep moving the camera. If I up my time scale, now I'm multiplying by 7, so 2 seconds times 7 will be like 14 seconds have passed. Or I can make it slower by multiplying by some value lesser than 1. And here I'm scaling these two values. I'm scaling these two values here by the same value. I could create two scalars, make a vector tool or float tool, and use these as speed and change the speed there. But it goes the way you need to. Oops. So you do however you need to do to control the way you want to. But as you can see, you can do whatever you want and however you want. I'll delete these nodes. I'll create a base color. Because now I want to show you something about optimization. I'm changing the UVs for the texture with this math, and as you know, for each pixel on the screen, Unreal will do this math. For mobile devices, altering UVs is heavier than in PC, so you want to do this the optimized way. How is the optimized way? The way a shader works. A shader is the programming we do to control materials in GPU. The way a shader works is it has a vertex shader where it does math and operations on the vertices of the mesh, and then it has a fragment shader or a pixel shader that works for each pixel. What we are doing here in the material in Unreal is for the fragment shader. It does work for each pixel, but you can also optimize some things by sending their results for the vertex shader, so they will be calculated once for each vertex only. And texture coordinates are something Epic has made really easy to optimize. You select the material or click on an empty space, expand the advanced options here. If yours are collapsed, just click this arrow. And here in non-customized UVs, you change for how many coordinates, how many different coordinates you want to have. I want to have 1. You can see now I have an input here, customized UV. So I'll plug my UV, alt click to unplug from the color texture, and plug here in the customized UV. As you can see, the customized UVs have numbers just like the text scored. So the 0 means I'm altering the UV0 on the mesh, the first coordinate mapping. As the color texture by default use the first coordinate, you can see it's 0. It will be automatically using whatever I do here. So now my coordinates are being calculated once for each vertex. I'll compile here to show you. Now my coordinates are being calculated only once for each vertex. And as I told you earlier, the graphics card interpolates all the pixels in between the vertices to the blended coordinates between the coordinates in the vertices. So even though I'm altering the mapping in the vertices only, it will change it for each pixel, like I was changing it in the fragment shader. But it's a much more optimized way of doing it, because instead of calculating once for all of these small pixels here, you're calculating only once for each vertex. This cube has only 8 vertices, so it's really quick to calculate the 8 times versus, I don't know, thousands of times for each of the pixels. So remember this, anytime you want to manipulate the coordinate mapping of the mesh, do it using customized UVs, because they work in the vertex shader and it takes much less calculations to do it. I want to show you how I made this texture in Photoshop, how I mix channels together, but first there was one thing you may encounter here in Unreal and you want to know how to do it. There are some filters in Unreal for blurring textures, for example. Motion blur texture. So I have the motion blur texture. I'll put it in my base color, and I need at least a texture object. So I'll plug in my texture. Why can't I? Well, this is a float 3 value. And as it says in the error here, float 3 is not compatible with texture 2D. This requires a texture object. Texture objects in Unreal are almost the same as a texture, but it outputs a texture to be sampled from, not the channels. To create a texture object, you can either create one from the context menu, texture object, or right click your texture and choose convert to texture object. Now I can plug my texture object in this object input, but here we have an error, because these inputs require numerical values, and this is not anymore a numerical value. It's an object, it's something else entirely. So I'll unplug them and create a sampler from this object. So now I have the same channels I had before, but coming from a texture object. Metallic, roughness, and opacity mask. So as you can see, my texture was blurred, and I'm still using my channels individually for effects. I'll compile this, and now in my material instance, you can see I don't have the option anymore to change my texture. So what you can do is take the texture object and convert. Oh, I remember now. Unreal doesn't have the option to convert a texture object to a parameter, but you can create a texture object parameter. Texture object parameter. It's the same thing. I don't know why they don't give the option for us to convert it to a parameter. Maybe one day. I'll call this texture. If you hold Ctrl and drag from an output pin, you can change where the lines come from or go to. I'll delete this, and now if I compile, I can change my texture in the material instance. See? Have you noticed? My main color is blurred, but the metallic channel, roughness channel are not. That's because in my material I'm using... Let me change this texture here real quick here. Okay. As you can see, I'm using the output of this function in the base color and the full texture sampled here for the metallic and roughness channels. So what if I want to use this in here? This output is probably a float 3 because base color accepts it. So yeah, it's a float 3. You can still use these channels individually by separating them. Unreal has those make 2, make 3 nodes, and it also has the break 2 and break 3 nodes. So you can use each float from these values separately. So my red channel was metallic and my green channel roughness. And now my roughness and metallic are blurred together with the rest. That's it for textures, and now let me show you how I did this texture controlling each channel separately in Photoshop. So the way I create separate channels in Photoshop is, I have here groups for each channel, so my red group, my green group, my blue group, and my alpha group. The alpha group, I like to leave it with a black background for itself, because when I make it visible, it will block everything behind it, and you'll see later why this is important. The other ones, I can mix them together, because when I change their colors, they'll have to be blended together. So the first thing you want to do is select all your RGB groups and put them in linear dodge mode, so they are added together. Secondly, right click each one of them and put the color you want them to represent in Unreal. So I'll go to blending options, and for the R I'll leave only the red color, and do the same thing for the other two. You can do this by just double clicking outside of the group name. This is my G group, and this is my B blue group. So because of the linear dodge mode, add as it says here, I'm adding these colors. And because each one of them represent a single channel in the texture, they can be added together without affecting each other, because green plus blue will not change the blue or the green channel, because in blue green is 0 and in green blue is 0. So you can add all of them together and after use the colors individually in Unreal. Now for the alpha group, the colors are already done. This is it. That's all you have to do. The alpha is a little bit different, because you don't have an alpha channel here in the colors, but you do have an alpha channel here in Photoshop channels window. You can see you have RGB, or if you want to see individually, you can see red, green, and blue channels. And this is how they will be recognized in Unreal individually, like black and white float values. How to do the alpha? Make your alpha visible, blocking everything behind. That's why I have a black layer here. Go to your channels, control click in your RGB, control click selects by value. So what's white will be fully selected, what's black will not be selected, and whatever is in between gray values will be selected with an intensity according to the gray intensity. So control click RGB to select the white values and the gray levels accordingly, and down here click this button. It creates an alpha channel from your selection. So if I make all of them visible at once, you can see in red what's my alpha channel. So now if I hide this, I'll unselect this, Ctrl D, and save my file. You can see in Unreal, in my texture, that I have the channels as I wanted. You can check this here in View, and you can isolate each channel. So this is my red channel, this is my green channel, my blue, and my alpha channel. I'll leave this PSD file for you to download if you want to. And just something else I like to do to be easier to remember what each of these represent is rename them as the way I'm using in Unreal. So this would be roughness, this would be metallic, this is a texture, it's a mask. This is a mask, and this is opacity. And color these groups as their respective channels. So right click here in the left side of the layer and red, right click here green, right click here blue, and right click here gray for alpha. That's just easier for me to remember. Another thing you can do is create actions for changing these. So for example, if I had this no color, no blending mode edited, so it's in default. I could open my actions. You can see here I already have actions for alpha, blue, green, and red groups. So I'll create another one to show you here. New action, set red group tutorial record. So now it is recording. I have a layer selected, so remember to select the layer before you activate this action. I have a layer selected, I'll right click my layer or double click it, choose leave only the red channel active, right click here and set its color, and stop recording my action. Oh, and I forgot to record setting the layer mode to linear dodge, so I have to change it to any other layer mode. I'll start recording again and set it to linear dodge and stop recording. Now it does everything for me. So if I created another group with the default settings, I could only click this group, select the action, and play. So now it's a red channel group, and everything inside here will affect only the red channel. To create the alpha channel action is a little different, because first you have to delete whatever alpha is here, because Photoshop can create alpha 2, alpha 3, and Unreal won't recognize it. So the act of deleting this alpha. So I'll duplicate this and set it to all the defaults, and I'll create the action. So my actions, new, set alpha group tut record. Remember, your layer has to be visible before you start recording the action. So every time you're gonna use the action, make the layer visible, then use the action. So then I go to channels, remove this alpha by clicking here on this garbage can. Yes. Ctrl click my RGB channels and click here to create an alpha from the selection. That's it for the actions. Stop. And now I have an action that converts any layer. Oh, I forgot. Start recording again. Set the layer color to gray. Now it's okay. I stop recording. Oh, and I forgot another thing. Deselect the selection. Ctrl D. Okay, now I think I did everything. So that's it. Now I have an action to create the alpha channel from a group. So if I delete this group and contents, I'll change this group just to show you that it works. So I select the group, it's visible. Remember, it will use the RGB intensity here, so it has to be visible. Now select the action and play. Now my alpha channel is like that group. Always remember to use Photoshop actions to speed up your workflow. As you can see here, I have an action for each of the channels, the red, green, blue and alpha. I hope you learned a lot from this video. If you liked it, click like and subscribe. Also, tell your friends about it, because the more people watch my videos, the more I can dedicate my time for doing tutorials. And remember, this is a series on materials that will be getting more and more advanced, so it's really worth subscribing now. If you want to learn something specific, leave a comment and I'll do a video on it. Thanks for watching, until the next video. Of the individual channels. Of the individual channels. What mapping or UVs are? What mapping or UVs does? What mapping or UVs are? Mapping or UVs are the way you map. So what you can do is take the texture object and convert.
Hello darkness, my old friend.
Oh, I remember now.